Hello and welcome to another video. This is an A-level maths video on Pure Maths Year 1. We're still looking at Chapter 1, working our way through. Today's video here is on Section 1.4, which is to do with negative and fractional indices. So expressions involving powers or indices where that power is maybe a negative number or maybe a fraction or maybe even a negative fraction. So we'll see how we get on with that. Now, as with quite a lot of these Chapter 1 videos, I'm sure there's not really much in this chapter or in this section which you haven't seen before if you're starting an A-level maths course. But what I'd like you to do is have a look at the question and see if you can use the rules that we've already talked about in earlier videos to prove and explain why the result on the screen is true. Okay, so pause the video, have a go at that and restart when you're ready. Okay, so how did you get on with this one then? So let's see if we can work out what's going on. So if we have our a to the power of a half multiplied by another a to the power of a half, well, the rule that we saw in an earlier video, which we should be familiar with, means that we are going to add together those powers. So that power just becomes a half plus a half, which is of course just a to the power 1. Now, what's a simpler way of writing a to the power 1? Of course, that's just a. So what we've ended up with here is we've ended up with a number which, when we multiply it by itself, gives us this answer a. Well, what that must mean, of course, is that that number that we multiplied by itself to give us the answer a must be the square root of a, because that's the definition of what a square root is. And there's our answer. Now, I'm not going to go into the proofs of all of these other results here because that's something which you can have a look at in your own time if you're interested. But the other results that you can see on the screen here are results which I'm expecting you to be familiar with and which we can prove or justify in very similar ways to the one we've just done there. Take a look at the ones on the screen. See if you're unfamiliar with any of them. We're going to talk about one or two of them in the rest of this video, but we'll do that very shortly. Okay, so because I'm expecting pretty much anyone who's starting an A-level maths course to be already familiar with these rules, we're going to jump straight in with quite a complicated one here. We're going to do this one together. So on the screen here, I've just asked us to have a look at this situation without using a calculator. Evaluate 64 to the power of negative 2/3, or negative 2 over 3. Let's see how we can do that. Okay. So the first thing I'm going to look at when I start this question is I'm going to look at this negative power, and that's going to tell me that I can write that as 1 over 64 to the power 2 over 3. So what I'm doing there is I'm using the second rule that you can see on the list at the top of the screen there. A to the minus m equals 1 over a to the m rule there. Okay, so that's my first stage. I've dealt with the negative power. I still have this power 2 over 3 here that I'm going to deal with. So what can I do with that? Well, looking at the fourth rule there on the screen, I can see that what I've got underneath this fraction is I'm going to have 64, which is the base, of course, and then we're going to take the cube root of that, and then I'm going to square the answer. So that's how I deal with the 2 and the 3 in this fraction here, the 2 and the 3 in the power. Okay, so let's work out what that is. The cube root of 64. So that's the number which, when I cube it, it gives me the answer 64. Well, I think that must be 4. 4 times 4 is 16, multiplied by another 4 gives me the 64 that I need. So that works out. Of course, that's still being squared. And so my final answer here is 1 over 4 squared, which is, of course, 1 over 16. Now, I know that I said that we weren't going to use a calculator to work out the 1 over 16 we've got over here, but we may as well just check on our calculator to see if our calculator agrees and make sure we can actually use our calculator functions to do this as well. So let's just go to our calculator and just work out what the calculator says. So 64, here's the power button just here, and then we've got minus, hit the fraction button so we can have 2 over 3, hit equals, and look at that, 1 over 16, the calculator agrees with us. Okay, now it's your turn. So without using a calculator to work this out, I would like you please to evaluate 9 to the power of minus 3 over 2. Pause the video, restart when you think you've got an answer. Okay, let's see how we get on with this one. Do you agree with this? 9 to the power of minus 3 over 2. Dealing with the negative in the power, that becomes 1 over 9 to the 3 over 2. And then using that fourth rule on the screen there, we can deal with the power 3 over 2 here. Now one way of saying that is that we're going to have 1 over, the 9 is going to be in a square root, and then of course we're going to cube the whole thing. So see how that works? We've got the cubing there from the 3, and we've got the rooting there from the 2. It's a square root because it's a 2. And again, this should be something we should be able to do without a calculator quite easily. The square root of 9 is of course 3. So we end up with 3 cubed here. And 3 cubed, 3 times 3 is 9, multiplied by another 3 gives us 27. So the answer there is 1 over 27. Okay, time for some algebra now. So let's bring some algebra into things. Here's a question which I'd like you to have a go at. We've been given an expression there, q, which equals to 9p cubed, and we've been asked to express 5 cubed to the power of a half in that particular form you see there on the screen. So what you're going to need to do is you're going to need to substitute, wherever you see q, you're going to instead substitute 9p cubed, and then you're going to simplify it into that form. Okay, pause the video, see how you get on. Okay then, let's work through this one together. Let's see if you agree with this. So we have here q equals 9p cubed, that's what we're told. And we need to say what 5q to the power of a half is. Well, q is of course 9p cubed. So we're going to have 5 lots of 9p cubed to the power of a half. And now we've got to use our indices rules to simplify it and get it into the form that we want. Okay, so let's see how we can do this. Right, well first of all, I'm going to notice in this bracket all being raised to this power, one of our rules we looked at in an earlier video says that we can write that as 9 to the power of a half multiplied by p cubed to the power of a half. And of course we've still got the 5 at the front of this thing multiplying it all together. So let's see what we can do with that. Well, 9 to the power of a half. Power of a half means a square root, right? So again, we've got our square root of 9, which is going to be 3. And then we've got another one of our power rules, which we looked at in an earlier video, which says if we got this situation where we've got something being raised to a power, and then that whole thing is also being raised to a power, these powers can multiply together. So we're going to have p to the power of 3 multiplied by a half. Well, I think the easiest way of saying that is just 3 over 2. So just simplifying that a little bit, 5 times 3 is of course 15. We've got p to the power 3 over 2, and we've got that in the required form, and we're done. Okay, finally for this video then, I'm going to give you quite a challenging question. I think this one's quite a difficult one. You might need to think carefully about how you're going to tackle this one. But see how you get on with this one. Give it a pause. Make sure you think about it carefully before you restart. Don't give up too easily. And have a go at this question, please. Okay, I thought this one was quite tricky. So the key for this one here is that we need to try and get the expression we've got in terms of 2 to the x. We need to find a 2 to the x kind of lurking within the 1 over 4x. Sorry, let me say that again. 1 over 4 to the 3x that we've got here. And I think the breakthrough happens when you recognise that you can write 4 as 2 squared. So if you have 2 squared instead of 4, then of course this is getting us closer to getting the 2 to the x that we want to get here. Now let's see if we can use some power rules to simplify this a little bit and write it in a different way. Now of course we've seen this rule in the previous question. When we have something raised to a power and then that whole thing is raised to a power, those two powers can get multiplied, right? So we can write this as 1 over 2 to the power of 6x. Okay, we're getting a bit closer. We want 2 to the power of x here. So again, we need to be a bit clever about this. I think what I can do here is I can recognise that I can write this as 1 over 2 to the x raised to the power 6 here. Now, why have I done that? Well, the reason is because I just want to get that 2 to the x by itself, and now I can write this as 1 over y to the power 6. So wherever I see 2 to the power x, I can instead write y, and that's really what I was trying to do with this question. Okay, so I could leave my answer like that. It does say simplest form. Well, I think that's quite simple, or you might prefer to write this as y to the minus 6 using that power rule that we've got there. So either way, I think we've done it and we've got our answer. Okay, then we've reached the end of the video. So more practice questions here. Exercise 1D in the textbook, it's on page 11, and that's the end of this video though. We'll be back again shortly with the rest of the chapter.